Higher Maths Essential Skills, Exercise 9. In Exercise 9 we are looking at splitting up fractions and writing them as single terms, or different terms, sorry. So x squared minus x cubed all divided by 2x squared. So one or two of you will have been looking at this and think, well, that cancels with that. Unfortunately, that is not the case, because we need to cancel, if we're dividing by x squared, we need to divide every single term by x squared. We can't just choose to divide this first term by x squared. That's not mathematically correct. It doesn't give the correct answer. So we need to split it up into two separate fractions here. So x squared divided by 2x squared minus x cubed divided by 2x squared. Okay. Now once we've done that, we have x squared divided by x squared, which is just going to be, which can simplify to 1 over 1. So we're left with 1 over 2 times 1, which is a half. X cubed divided by x squared. So hopefully we just look at that and we think, oh, okay, that's just x. And we've still got the 2 here in the denominator, so it'll be x over 2. If we're thinking, well, I'm not really sure where that comes from. So remember, if we are dividing fractions, we are using this rule. Okay, so x cubed divided by x squared would be x to the 3 minus 2, which is x to the 1, and x to the power 1 is just x. Okay, so that's where that comes from. So we'd end up with 1/2 minus x over 2. Right, question F. So getting a bit tricky here. This type of question is probably beyond what you would see in a National 5 exam. But in higher, when we cover calculus, which takes up approximately 1/3 of the higher course, so 25% of the higher course, we need to be very, very secure in our indices rules and being able to split a fraction up into 3 separate terms as we have done here. Okay, this allows us to do something called integration or differentiation, which we look at during the higher course, but we just need to be really, really, really good at doing it. Okay, if we learn that now, then when it comes on to differentiating and integrating, pupils normally don't struggle with the idea of differentiation and integration, but they do struggle because their National 5 indices knowledge isn't as good as it should be. This will hold you back if you can't do this, guys. So spend the time now and it'll pay off later on in the year. Trust me. Right, so we need to split this up into 3 separate fractions. We're dividing everything here by x to the power 4. Okay, so 3 separate fractions. Now, again, just like we did in the previous question, we are using this law of indices. This law here. Okay, so I know I'm going to be subtracting the indices or the powers here. So over here I've done 2/3 minus 4. So I need to turn 4 into 12/3. 3 wholes, 1 whole is 3/3, 2 wholes are 6/3, 3 wholes are 9/3, 4 wholes are 12/3. So 2/3 minus 12/3, which will be negative 10/3. So x to the negative 10/3. In the same way, here 3/4 minus 4 wholes. Again, 4/4 is a whole, 8/4 2 wholes, 12/4 3 wholes. So 16/4 will be 4 wholes. So it'll be 3/4 minus 16/4, which will give me x to the negative 13/4. And then 2 over x to the 4, we're just going to leave like that. Okay, then what have I done at the end? Remember, negative power, we can move down. Just remember, what have we got here? We've really got one of these. We've really got one of these as well. So it becomes 1 over x to the 10/3 plus 1 over x to the 13/4 plus 2 over x to the 4. Now, I've not checked the answer to this in the back, but it might say x to the negative 10/3 plus x to the negative 13/4 plus 2x to the negative 4. If it does, this answer is totally acceptable. Okay, if you've written your answer in a slightly different format, that is fine. It doesn't specify in the question how to write it. The question does start off with a positive power on the denominator, So the answer should probably be written like that, but in the back they might not have done it that way. Okay. So if you're looking at your answer and you're thinking, oh, I've got this one wrong, what am I doing? Sometimes you've just written it a slightly different way. Look at your answer, look at the answer in the back, see if your answer is actually the same. Right, on to L. So quite a tricky exercise, this one. Ask me if you need more help. I can do more videos, not a problem at all. So 6 multiplied by the cube root of x plus 2 multiplied by the 4th root of x to the power 5, all divided by the cube root of x to the 4. Okay, so remember, we have this rule. And after use that rule to get to rewrite the question into a fractional index form or fractional indices form. So here I've got x, or x to the power 1 cube rooted. So using this, that'll be 6x to the 3rd. I've got x to the 5, and then taking the 4th root of that. So top number's the power, bottom number's the root. So it'll be 2x to the 5 quarters. For the denominator, x to the 4 thirds again. Top number's the power, bottom number's the root. Okay. Again, split it up into 2 separate fractions. So here 6x to the 3rd over x to the 4 thirds. Well, 1/3 minus 4 thirds is minus 3 thirds, which is minus 1. 3 thirds are a whole. So that'll be 6x to the minus 1. And then we have x to the 5 quarters divided by x to the 4 thirds here. So if we're dividing, we can just subtract the powers here. So here's the working for that. Again, we're really back to those adding and subtracting fractions with different denominators that we worked on in S1 and S2. Okay, so we need to be good at this. So gone for a common denominator, work my way through and come out with 2x to the negative 1/12. Question number 2. 2C. I've gone over this one because one or two of you will probably be thinking, oh, 1 squared and x squared. Of course, that's not how we expand a double bracket. We need to be thinking of doing FOIL. I don't know why I put that in a bracket. There's no need to do that. Okay, so first term is 1 times 1 is 1. Then 1 multiplied by minus x times 1 for the inside terms, and minus x times minus x at the end. So that tidies up to give that. And then going back to the question, we're going to have to divide all of this by 2x. So again, I've split it up into 3 separate fractions. X divided by x is 1, 2 divided by 2 is 1, or 2x divided by 2x is 1. So that simplifies. And x squared over x will just be x. So I'm left with x over 2. Question D. So similar to the last one. So 3 over x minus 4. So again, I've got a square bracket. I'm going to write bracket times bracket. Then I'm going to do 3 over x multiplied by 3 over x. Top times top, bottom times bottom. That's 9 over x squared. 3 over x multiplied by minus 4. So I'm doing 3 minus 4 is our minus 12 divided by x. Minus 4 times 3 over x. Minus 4 multiplied by 3 again is minus 12. And then divided by x. And minus 4 multiplied by minus 4 is, of course, plus 16. And then these two middle terms tidy up to give that final answer. Of course, if you're happy enough to square a bracket in your head in a question like this at higher, you'd essentially be getting your mark for going from this line to this line. So if you're expanding your double bracket in your head, that's fine at higher, to be honest, guys. H, again, this is a question as higher pupils, as you'll find later on, will catch a lot of you out. Of course, if you're putting in the work now, hopefully later on it will pay off. So we need to square this bracket. So I'm going to square this bracket in the same way that I squared the bracket in 2C. So that'll give me x squared plus 4x plus 4, all divided by x root x. So I need to think about this as a fractional power, so let's move over because I've written it here. So x is x to the 1, root x is x to the half. Multiply those together, I'll get x to the 1 plus 1 half, which is x to the 3 halves. We do like a top-heavy fraction in higher maths, guys, so I wouldn't want to see you writing x to the 1.5 or x to the 1.5. If you have written that when doing this, that's okay, but get out of the habit of doing that and embrace a top-heavy fraction, because that's what we want. The reason why that is because this can be written as the square root of x cubed, and we need to go from this format to this format quite a lot, which is why we like a top-heavy fraction. Right, so back onto the question. So we're dividing x squared by x to the 3 over 2, 4x by x to the 3 over 2, and 4 by x to the 3 over 2. Again, now we're just going to subtract, so 2 wholes is 4 halves, minus 3 halves is 1 half for the index. This is x to the 1, so that'll be 1 minus 3 halves, so that'll be x to the minus half. So I can just move that x to the minus half that would have been on the top straight down. And that is 4 over x to the 3 over 2. So I will just write down where that middle term came from again, because I might have just missed out a little bit of working, which might be exactly why you're looking at this video. Okay, so this middle term from this line to this line, what exactly happened? Well, that's 4x to the 1 minus 3 halves, which is 4x to the minus 1 half, which is 4 over x to the power 1 half. And that is the end of the extra help on exercise 9.